Sometimes I kind of notice that, and I always am kind of wondering what's the reason for it. So, find me a geometry student that's covering circles and chords. You're the first geometry student that I have, and I've got like 6 or 7 from Chatfield that's gotten to circles. I couldn't believe it. I couldn't figure out what everybody else has done. They've skipped these sections. Must be the fact that you're in honors. This is probably going to be the last new thing you learn before you start reviewing for your semester final, is my guess. All right, where would you like to start? With 1, 2, or 7, or you want to go over each one of these, or?
Let's see. I don't know. Let's start with 3.
Okay. So what is B? What is this point right there?
The side of the circle.
It's the point of tangency. It is the point that this line, BH, touches the circle at exactly one point and one point only. That's called a tangent line. Okay? So B is the point of tangency. What is BH?
BH is a common tangent.
Yeah, it's a tangent to circle C, and it's also tangent to circle G. So of these answers here, it's the common tangent to both circles. It could also be F. It's obviously a tangent to circle C or circle G, but if they want, a one-to-one matchup here. Okay, what is AB?
A tangent?
It's a chord. Notice AB is not touching the circle in one place only. It's cutting it in 2 spots. If I draw from A to B, it cuts this circle there and there, both of which are points of tangency, but the line AB is not a tangent. AE is a tangent, and BH is a tangent line, but AB is not. It's not tangent to anything. It's a chord. A chord is basically, if I have a circle and I connect one spot of the circumference to another spot, that's a chord.
But isn't
that's all
number 6? Because it stops? Doesn't continuously go?
Well, whether it continues or not doesn't really matter. None of the other definitions fit. It's still a chord. It's a chord that intersects the circle. So, in other words, it's the same thing as if I did this. That's still a chord. Cuts the circle in 2 points, as opposed to a tangent line, which cuts the circle or just touches the circle at 1 point and 1 point only. One of the things to remember about a tangent line is if I connect the point of tangency with the center of the circle, always makes a right angle. Very important fact. So any tangent line makes a right angle. In other words, I cannot have the following situation where this would be like a 70-degree angle. That's impossible. If that were the case, this would not be a tangent line. Now, the fact is that any straight line that touches the circumference in one spot only of a circle is a tangent line. So it's always going to make a 90-degree angle as long as it is a tangent line, as opposed to a chord that wouldn't have to make a 90-degree angle. If I drew a chord, something like that, well, this doesn't have to be 90 degrees because this is a chord. It's touching the edge of the circle in two spots. Oh, I see what's going on here now. The first question was line segment AB, and then number 6 is the total line AB.
Yeah, that's why I asked that, because they're the same thing but different.
Good question. Good question. You're absolutely right. Line segment AB is a chord. The full line AB is a secant line. I apologize. I made a mistake. If I take a circle and I draw that, that's a secant line. If I have a circle and I do this, that's a chord. AE, the full line AE is what?
A tangent.
Yeah, and it's not common to any other circle, so it's just a tangent line. How about G?
That's the center.
Line segment CD.
A radius.
And line segment BD.
Diameter.
Correct.
These are easy.
Yeah, they are pretty easy. Let's see if we can find us a tough one. About 12. What's the radius of circle C?
3.
Okay.
And 6 is the diameter.
Let's look at 14, where they want us to draw a common tangent. A couple of ways we could do this. Have a big circle intersecting a smaller circle whose center is right on the big circle's circumference. Now, it says, copy the circles, then draw all common tangents. Well, let me draw one common tangent. How many others are there?
Just one.
Correct. This one down here.
Yeah.
Common tangent is exactly what it sounds like. It's a tangent. It's a line that is tangent to two different circles. How many common tangents on 15 are there?
Four.
Correct. Because on 15, since the circles don't connect, I got a tangent there. I got a tangent there. And then I have what's called a, I forget the term, but
isn't it the interior?
Yeah, the interior common tangent and the exterior common tangent. So there's two interiors and there's two exteriors. So this one would have 4. Let me go back to the previous example and make sure I didn't miss any here. Yeah, notice that this one only has exterior common tangents. There's no interior common tangents.
So it can't go through the circle?
Correct. In other words, a common tangent has to have one point only touching the circumference. If I were to try to draw in other words, some line like that, it's tangent to the small circle, but it's not tangent to the big circle. So in this situation here, you only have two common tangent lines. In this situation, you have four. About 16.
16 is none.
Correct. Any point of tangency to the small circle would necessarily intersect the larger circle in two different spots. No matter where I draw that tangency, it's going to intersect the big circle in two spots. It's impossible to draw it where it intersects precisely in one spot. And 17.
It should be 1.
Correct. Only 1. Right. Whoops. Right there. You had 2 documents, didn't you?
Yeah, there's like a second page.
Okay. Is AB tangent to circle C, and why? If yes or if no.
Yeah, because it hits CA hits AB at a right angle.
Yeah, in other words, we cannot have a 3, 4, 5 triangle without it being a right triangle. This is automatically a right angle. And because that's a right angle, this line AB has to be tangent. If it was not tangent, that would not be a right angle. In other words, all of these theorems work in reverse. If I have line AB tangent to circle C, it's going to make a right angle, and vice versa. If a line makes a right angle with the radius, then it is a tangent line. About 19.
I would have to do the...
Correct. But you got to figure out whether that's a right triangle. So what equation has to be true?
C squared equals the square root of...
No, if you're going to say C squared, it's not the square root of.
So then
C squared equals A squared plus B squared. That's the Pythagorean theorem. Now, you could have been perfectly fine if you said 18 has to equal the square root of 9 squared plus 15 squared. That's really saving you a step. Okay? Now, does it? In other words, what's the square root of that? What's the square root of 306? Is it 18?
So it's 81 plus 225 equals...
Tell you what, let me give you a little secret. You won't have to use your calculator to solve this. 18 squared, what's the last digit have to be?
9.
4.
4.
18 times 18. 8 times 8 is 64. So the last digit has to be a 4. In other words, this is the square root of 324 is 18. So the moment that I'm looking at the square root of 306, I know that that cannot be 18 because the last digit has to be a 4. And that's true with any number. If I said, what's the square of 16? Well, you know the last digit is to be 6 times 6, so it has to be a 6. If I said, what's 17 squared? You know the last digit has to be a 9. So on problems like this, you don't actually have to solve them. You just have to know that it's not the correct answer. In other words, all I have to know is that the square root of 306 is not 18. And if it is not, then AB is not tangent, even though it looks like it is. They've drawn it to make it look like it is tangent. But in reality, if I were to blow that thing up, it would look something more like this. In other words, it would actually cross at multiple points, not just one point. Merely because we know that 9 squared plus 15 squared is not equal to 18 squared. That's all the further we have to get. We don't need to solve for that angle. We just have to show that it's not equal to 90 degrees. And we can show that by proving that 9 squared plus 15 squared is not equal to 18 squared. Determine whether AB is tangent to circle C. Okay. They've kind of drawn this problem like it was a three-dimensional solid, and that's why I questioned it at first. But it isn't. It's a circle over there. Everything's in 2 dimensions here. That's 48. That's 52. And that diameter is 10.
I did 52 equals the square root of 48 plus 10.
No, they didn't ask about this line here, whether it's tangent or not. They only ask about this line here. AB, right?
Oh, okay.
Determine whether AB is tangent to circle C.
So that needs to be 48 equals square root of 52 minus 10.
Well, if I had that line right there going to the center of the circle, well, I know that's 5. All right, I see what's going on here. If I have 2 intersecting tangent lines, they have to be equal. If that's 52, that's 52. If that's 48, that's 48. You cannot have 2 tangent lines intersecting outside the circle. If they are both tangent lines, they are equal. So this still doesn't answer the question, does it? In other words, I know that both of these are not tangent lines. Otherwise, they would be equal. But does that tell me if AB is tangent or not? Not really. Hold on a moment. Wow. Question is this a right angle? That's the only question. Since they're only asking about line AB, they don't even put a letter up here. So they don't even want to talk about that line there. If AB was tangent to that circle, then this distance right here would have to be what? Well, we can solve this. I don't know if we can solve it in 3 minutes, but I think we can. What would this distance right here have to be? That's not going to answer the problem either. The more I look at this problem, the more we cannot tell whether AB is tangent or not.
I don't know.
Well, no, I think it's a typo. I don't think we can tell. In other words, maybe that's the proper answer. Maybe you can say to number 20, determine whether it's tangent, and you can't determine from the available information. I know that both of those lines are not tangent, because if they were, they would have to be of equal length. But to determine whether AB is tangent or not, I have to determine if that angle is a right angle. And as all I know is side 48 and side 5, but they haven't given us any information about what the distance of this middle line would be if I drew it. And from the way they've drawn this line, I can't even assume that it's 50, because I have no idea. That clearly doesn't look like it's tangent, but how far in it goes, I don't really know. So I can really determine nothing about the center line. Might be missing something with this problem. I probably am, but I would say AB, you cannot tell whether it's tangent or not. Not as long as that, it doesn't even matter if that 10 is a radius as opposed to a diameter. Yes, sorry. Let's rework everything here. Good, glad I spotted this before I hung up. This triangle, the whole triangle, where this is side 52, this is side 48, and this is side 10. You see what I'm looking at?
Yeah.
If that is a right angle, then AB is tangent to the circle. So, for that to be a right angle, we got to have 52 squared equals 10 squared plus 48 squared. Well, again, 52 squared ends in a 4. This ends in a 4. That may very well be possible, that 52 squared is equal to 100 squared plus 48 squared. You have your calculator? Can you figure that out?
Yeah.
I suspect it probably is equal to it. And that makes that a right angle.
It says that so 52 squared is 2,704, but
What's 48?
100
What's 48 squared?
is 2,304. So they're not equal.
They're not equal. So this is a not equal. If they're not equal, that's not a right angle. If that's not a right angle, then point AB is not tangent to it. All right, Quade, I'm going to have to run because I have a 5:30. It's always a little tough for me to get from one appointment to the next. That's why I was a couple minutes late to start with. But
that's okay.
You don't need to worry. If I live and breathe by my calendar, so if you're on that calendar, I'll be there. I may be a couple of minutes late occasionally, but
that's right.
Okay.
All right, thank you.
I will talk to you next time. Bye-bye.